So the first set of directions are going to ask you to add or subtract, and they're going to ask you to list your excluded values. So if we kind of go back to the 4th or 5th grade, we learned that we could not add or subtract fractions unless we had a common denominator. So some of the first problems in your homework will have common denominators because they'll be the easier problems, and then we'll get into those problems that do not have common denominators, and I'll show you actually how to find the common denominator. But if you'll notice in this problem, the two denominators are exactly the same. So then we can go ahead and write these two fractions. We can literally add them up, combine them up, and put them as one big fraction. And we keep the same denominator. Alright, we're not going to add denominators. When you're adding and subtracting fractions, the denominators have to be the same, and you'll combine the numerators. It's always a good practice to keep what you're combining in the top in parentheses, because sometimes you're subtracting, and when we're subtracting a polynomial, we have to remember to distribute the -1. So it's just always a good habit to keep your numerators in parentheses. Once you start working these problems and you get really good at them, if you want to leave this little step out, you can. But in our notes today, I'm going to show you how to keep those parentheses in to make sure that you don't make any mistakes. So if you're adding, we know that we can literally drop the parentheses and just combine like terms. So we can probably do that without any work. What's going to happen with the -4x and the +4x? They're going to cancel out, and then in the top you're going to be left with x squared minus 4, and in the bottom you're going to be left with x squared minus x minus 6. So this is a fairly simple problem. You already have a common denominator. You're writing that as one big fraction and adding your numerators together. And then you need to say, can my answer be simplified? My answer is a fraction, so it can be simplified. And this is where last night's homework comes in. So is x squared minus 4 over x squared minus x minus 6 simplified? No, it's not simplified because I have some factoring to do, and maybe those factors will cancel out. All right? So I'm kind of running out of room. I'll come up here. So x squared minus 4 is the difference of squares, and how does that factor? X plus 2 times x minus 2. The bottom is a trinomial. My signs are different. And how does that trinomial factor? Three and 2. What needs to be positive? What needs to be negative? 2 needs to be positive, 3 needs to be negative. Any questions about how I factored? Alright, because I'm simplifying, I'm going to factor to see if anything will cancel. Will anything cancel? The x plus 2's will cancel. And so my simplified answer is x minus 2 over x minus 3. Alright, that's your simplified answer. You do have to list your restricted values, so you're going to go back to your original denominators here. Your original denominators are the same. It's not factored, so you might want to go somewhere where you factored it, or where did we factor it? Up here on the top. The x plus 2 times the x minus 3, those are the factors of the original denominator, and what can x not be if you look at the factors? -2 and 3. -2 and 3.
Would it be positive 2 also because you have 2 minus 2?
You're only looking at original denominators here. So the original denominator factors into x plus 2 times x minus 3.
Oh, okay.
Yeah. You're not going to look at the top for an excluded value unless you're dividing by a fraction. And then that's the only time you look at the top and the bottom. Alright, so we're going to do a few that already have common denominators, and then I'll show you how to find denominators. Alright, 38. So we have 2x plus 3 over 3x minus 6 minus 3 minus x over 3x minus 6. So again, we can't add or subtract fractions. unless we have a common denominator. And they were nice to us. We already have a common denominator. So we can go ahead and combine these two fractions. Again, I'm going to suggest that you use parentheses until you really think you know what you're doing. You might want to always use parentheses. It's just a safe thing. Since I'm subtracting this time, before I combine like terms, I have to distribute a -1 into the second parentheses. So I'm going to slide over here. So I have 3x minus 1, 3x minus 6 on the bottom, and then I have 2x plus 3 minus 3 plus x in the top. If you're subtracting, you have to remember to distribute a -1 into your parentheses. Then you're going to simplify the numerator. 2x and x combine to be 3x. 3 and -3 will cancel, and then you put that back over 3x minus 6. Alright, so that's your answer right now. You have to ask yourself, is it simplified? Which really means, will anything factor and then cancel? Will anything factor? Yes. In the bottom, how will the bottom factor? Greatest common factor of 3. When you factor out of 3, what are you left with? X minus 2. And what will cancel then? The 3's will cancel. So your simplified answer is x over x minus 2. And then you're going to go back to your original denominators. Alright, here are your original denominators. They're not factored there, but it's a pretty simple denominator. So can you think of right there what x can't be that would make the denominator go to 0? 2. If you can't see that 3 times 2 minus 6 is 0, then you could go where you factored, which is right here, and you could see that x cannot be 2. Any other excluded value? That's the answer. Okay, so that's the basics. That's when you have two problems that have a common denominator. Can you think of anything to ask about those two? Because those are the easier problems when you have a common denominator. All right, number 42. 42 is not going to have common denominators, and I'm going to show you how to find a common denominator. So they're asking us to add 8 over x minus 2 plus 2 over x minus 3. And we know, since the 4th and the 5th grade, that we can't add or subtract fractions unless we have a common denominator. So in algebra, if we have things like x minus 2 and x minus 3, we actually just multiply those two factors together. And that's how we find our common denominator. So y'all remember, like in the 3rd grade, or not the 3rd grade, but maybe the 5th grade, when you had a denominator like 5 and 22, and you were trying to find the common denominator between 5 and 22, sometimes you just said, hey, let's just multiply them together. Y'all remember doing that? You're trying to find a common denominator and you can't think of one, you can just multiply the two denominators together and that will give you a common denominator. That's what you do with algebraic expressions. So you're just going to take those two denominators. They're going to need to be factored, and they are in this problem. X minus 2 is already factored, and so is x minus 3, and you're just going to multiply them together. All right, so let me get your brain thinking for just a second. So if I go back to 5th grade, and I'm trying to change my denominator, so I'm going to give you something fairly simple to think about. So I want to change the 3 into a 15. So remember that process? You say 3 times what is 15, and 3 times what is 15? 5. So if you multiply the 3 times 5, you have to multiply the 2 times 5. And so 2 times 5 would be 10. So you're doing the same thing with this. It's just more complicated because you have the variables. So look at your old denominator. Here's your old denominator. What are you multiplying it by to get your new denominator? You're multiplying x minus 2 times x minus 3. So you got to multiply the top by x minus 3. Okay, go to the second denominator. It's x minus 3, and we're trying to turn it into x minus 2 times x minus 3. So what did I multiply that denominator by to get the new denominator? X minus 2. So you have to multiply the top by x minus 2. Alright, a lot of people get a little bit confused here and they think they can go back and cancel the x minus 3's right here. Don't do this, just watch. Why would you not want to do that?
Because then it gives you back your original.
You go right back where you started. The idea here is we are making our denominators larger so we can add or subtract our fractions. So don't cancel what you just did, or you're going to go right back where you started at. Okay? Alright, now we have common denominators, so we can write one big fraction. And we just put everything on the top. We have 8 parentheses x minus 3 plus 2 parentheses x minus 2. And we'll just simplify the top. The bottom stays the same. We'll distribute our 8 and our 2, and then we'll combine like terms. We're going to get 10x minus what? 28 over x minus 2, x minus 3. Any questions about how I got 10x minus 28? Okay, so this is our answer as long as it's simplified. So again, we simplify fractions that have x's in them by factoring. So the bottom is already factored. The top can factor. How can the top factor? You could take out a 2, but if you take out a 2, you're going to be left with 5x minus 14. And will anything cancel if you take out a 2? If you take out a 2, you got 5x minus 14. You can't cancel anything. So this is how they'll leave the answer. If you want to factor the top, you can. But if you factor it and nothing cancels, they'll probably just leave it as 10x minus 28. So there's your final answer. And what are your two excluded values? 2 and 3. Questions about 42? Anybody still copying? Alright, next one's 44. Again, we're not going to have common denominators to start out with. We're trying to subtract two fractions. One has an x in the bottom, one has an x plus 3. I can't subtract them unless I have a common denominator. So I'm just going to multiply them together. So my denominator is going to be x times x plus 3. And x times x plus 3. As long as your two denominators are factored, you'll just multiply those factors together to make a common denominator. Alright, let's write our equivalent fractions. What do we have to multiply the 4 by? X plus 3. And what do we have to multiply the 3 by? X. Any questions about that? Once you have your equivalent fractions with your common denominator, you can make one big fraction. And you'll have 4 parentheses x plus 3 minus 3x in the top. And then your job will just be to simplify the numerator. And your numerator is going to simplify to be x plus 12, and your denominator is x times x plus 3. So as long as that answer is simplified, meaning nothing will cancel or factor and cancel, then that's your answer. Will anything factor? Nothing will factor. Nothing will cancel because the x plus 12 has to cancel with another x plus 12. There's just an x in the bottom and there's no just an x in the top. So that's your answer. And what are your two excluded values? 0 and negative 3. Alright, you're probably wondering how can this get harder, right? Maybe. Maybe not. Alright, so this can get harder when the denominators are not already factored for you. Alright, so in number 54, we're going to look at two denominators that are not factored. And they're not common. So we're trying to subtract two fractions. They don't have a common denominator. And the denominators aren't factored like the previous problems that we've seen. So before you can find a common denominator, if your denominators are not factored, you have to factor them, or this problem will be 10 times harder than it's supposed to be. So 24 is negative, so I know my signs are different. And tell me what the factors will be. Negative 6 and positive 4. In the next trinomial, the 6 is positive, so the signs are the same, and they'll both be minus. Tell me what the factors are going to be. 6 and 1. Any questions about how I factored? Alright, so I have to find a common denominator. So you're going to multiply all the denominators together. So this time I have a common denominator already. Just one factor. What's in both denominators? X minus 6. So you don't need two x minus 6's, okay? If there's just one x minus 6 in each denominator, you just need an x minus 6. Doesn't matter what order you put these in. You need an x plus 4, and you need an x minus 1. You don't need the second x minus 6 because each denominator just has one of those. Alright, so this will work. Doesn't matter what order I'm putting these factors in, but you need each one of these three factors as your common denominator. Alright, so this is where they get a little bit more difficult. Alright, what am I going to multiply x by? The first x. X minus 1. What am I going to multiply the second x by? X plus 4. Anybody need me to explain that? Right, now we can write this as one big fraction where x minus 6, x plus 4, and x minus 1 is in our denominator. So then we have x times x minus 1 minus x times x plus 4 in our numerator. So now we're just simplifying the numerator. Right here. Excuse me. So we get x squared minus x squared minus 4x. And then bring down our denominator. Continue to simplify the numerator. And what does the numerator simplify out to be? Negative 5x. Again, it doesn't matter what order you have these binomials in the denominator. Would the signs not change? Well, I distributed a negative x. So the signs did change. Okay, so this is your final answer as long as nothing will factor and cancel. Negative 5x will not factor any further. And the denominator's already factored, so that's actually your answer. And you just have to list me your excluded values, and there are how many? How many? How many excluded values? 3. What are they? Negative 4, 6, and 1. All right, we'll do one more adding and subtracting, but that's about as hard as it gets. Questions about 54? All right. 58 is just where we're adding and subtracting more than two fractions. I've still taught, the concepts are still the same. We'll just make the problem a little bit longer just to make sure that you know how to do more than two fractions. Because somebody will text me and go, you didn't teach us how to do more than two. Still the same concept. Alright, so I'm going to stop talking and I'm going to let y'all guide me through this because I've shared enough information with you. I think that you can get me started. Anybody know what we'd do first?
You have to factor out the
Yeah. Before you find a common denominator, you want to make sure every denominator is factored. If you don't, then you're going to think x squared plus x minus 20 is part of your factor, and that's going to make your problem horrible. So you need to make sure everything's factored. 20 is negative, so my signs are different. And how's that trinomial going to factor? Come on, plus what? Plus 5 minus 4. Okay? What if you factor wrong? If you factor wrong, then your common denominator is going to be wrong. So make sure that you factor, take your time and make sure you factor correctly. Alright, so I need a common denominator. What is that going to be? X plus 5 times x minus 4. See, you know what you're doing and you don't even know how, right? Y'all ever have that feeling? You're like, I don't know what I'm doing, but I'm getting the right answer here. It's much easier to multiply and divide. I hate to add and subtract. Alright, how about that first numerator? What am I going to multiply it by? That's a trick question. Nothing. Okay? You're not going to change the first numerator because the first denominator didn't change. So you're just going to bring down 6x squared plus 17x minus 40. You are going to have to multiply 3 by something. What are you going to have to multiply 3 by? X plus 5. And you are going to have to multiply 5x by something. X minus 4. Alright? Then you're going to write... Now, since we've done several examples, I'm going to try to show you right here maybe how to skip a step. If this confuses you, then that's okay. So, do y'all understand that I'm going to distribute a positive 3? Do y'all see that? I have to distribute a positive 3, and I have to distribute a negative 5x. So I'm going to try to skip a step here. If this confuses you, then go back and do every single step. But on this next line, I'm going to go ahead and distribute. So I'm going to do 6x squared plus 17x minus 40. I'm going to distribute the positive 3 and get plus 3x plus 15. And then I'm going to distribute the negative 5x and get negative 5x squared plus 20x. Now I skipped a step that I put in every single problem. If you can't do that, okay, the thing that you have to be careful about is you're distributing a positive 3 and you're distributing a negative 5x. If that's too much for you, then show that extra step. Alright, we have to clean up the top. We got all kinds of stuff in the top. So 6x squared will combine with negative 5x squared to give you what? 1x squared. So I have an x squared. I have a 17x, a 3x, and a 20x. It's 40x. I have a negative 40 and a positive 15. Negative 25. Anything else combine? 6x squared minus 5x squared. Let's take care of that. 17x and 3x is 20x. 20x and 20x is 40x. Got that. Negative 40 and 15 is negative 25. All over x plus 5 times x minus 4. Alright, so we're getting close. This is my answer as long as it will not factor and reduce. So I do have a trinomial in the top. It looks like it might factor. So let's think about it. Since we have 25, so I'm looking for two things that multiply to be 25 that are going to combine to be 40. So 25 is pretty simple. The only factors of 25 are 1 and 25 and what? 5 and 5. Am I ever going to get a 40? No. So x squared plus 40x minus 25 won't factor. So nothing will cancel. So that's my answer. And what are my two excluded values? Negative 5 and 4. Okay? They don't get much harder than that one. Y'all are taking it pretty good. Alright, I have three more examples, and they're a little bit different. The directions change here. Everything that we've done, they're asking you to add or subtract. In the next set of directions, they're asking you to simplify. Any questions about 58 before we go on? Alright, next set of directions are asking you to simplify. And they're going to look kind of funky when you see this. And I actually have a shortcut for these problems. The book shows you this long, difficult way, but I can show you a little shortcut on these. So they're asking you to simplify this fraction. And the reason that it's not simplified is because you have a fraction in a fraction, and that's considered not simplified. So let me kind of give you a visual here. You have a little fraction in a big fraction. Does everybody see that? You have a little fraction and a big fraction, and that's considered a complex fraction, and that's not simplified. We don't ever want a fraction in a fraction. So what you want to do is you want to look at the little fraction, and you want to ask yourself, what can I multiply that little fraction by that would cancel out what's in the denominator? So in this specific problem, what can you multiply times 1 over x that will cancel the x out? Okay, so I'm going to write this over to the side to get you to think. What can you multiply times 1 over x that will cancel the x out? X over 1, or just x. Does that make sense? So you're going to ask yourself, what can you go look at the little fraction, okay? If it were 1 over y, then you would multiply it by y. Okay, if it were 1 over 3, then you would multiply it by 3. If it were 1 over 3x, then you would multiply it by 3x. So we want that little fraction to go away, because that's my problem. I have this little fraction in my big fraction, so I want to make that little fraction go away. So I'm going to multiply the top by x. So it's legal to multiply the top by something as long as you multiply the bottom by the same thing. It's legal to multiply the top of a fraction by anything you want as long as you multiply the bottom of the fraction by the same thing, and that's not changing the value of the problem. So you got to think of the top is actually a binomial because it's 1 minus 1 over x. So when you multiply 1 minus 1 over x times x, you're really distributing into your binomial. So you've got to do x times 1, which is x. You've got to do x times 1 over x. The x's cancel, and you get minus 1. So that's what you get when you multiply the top times x. X times 1 is x. X times 1 over x is 1, and that's a minus sign, so that's a minus 1. And then in the bottom, when we multiply x times xy, we get x squared y. Alright, so you need to look at that problem. Will anything factor and cancel? Will anything factor and cancel? Is that my final answer? That's your final answer. Nothing will factor and cancel. That's your final answer. Do you have any excluded values? And this time you have an x and you have a y that's in the denominator. So let's look at this denominator right here. What can that x not be?
0.
That x can't be 0. How about these two, this x down here?
0.
It can't be a 0. What about the y?
0.
It can't be a 0. So x can't be 0 and neither can y. So this little trick is something that you might use in equations when you have a bunch of denominators and you want to wipe out all those denominators. It's called clearing the fractions, and you find something that you can multiply through that clears the fractions. Alright, so that's the shortcut for that problem. Any question about 64? I have two more examples. Alright, 70. Same type of issue. They're asking you to simplify. This one's a little bit more difficult. How about lots more difficult? Alright, so this time I have how many little fractions?
2,
3 little fractions. I have the 6 over that stuff, the 1 over, and the 1 over. Those are all little fractions. Okay, so we want to cancel out all the denominators of the little fractions. So we're good except for that first denominator is not factored. So we'll need to make sure everything's factored or our life will be horrible. So 15 is negative. My signs are different. How does that first denominator factor? Do y'all know and you're just not telling me? Positive 5 and negative 3. Okay, so look at all of the denominators. We've got to find something to multiply 3 by that's going to cancel x plus 5, x minus 3, and another x plus 5. So we're actually going to multiply the top and the bottom by x plus 5 and x minus 3, because that's what's in all of my denominators. Whatever you multiply times the top, you can also multiply times the bottom. Alright? So you got to take all of this and you got to multiply it times this first term. When you take all of that and multiply it times the first term, everything in the bottom cancels and you're just left with a what? 6? Does that make sense? You're just left with a 6. When you multiply times this second term, only the x minus 3's cancel. And then you're left with minus 1 times x plus 5. Since that x minus 3 doesn't also have an x plus 5 in it, right here, only the x minus 3's cancel, and you have to do negative 1 times x plus 5. Only the x minus 3's cancel here, and you have to do negative 1 times x plus 5. And then on the bottom, when you multiply times the first term, only the what cancels? X plus 5, so then you have to do 1 times x minus 3. And then when you multiply times this term, nothing cancels, so you have to do 1 times x plus 5 times x minus 3. I might have lost some of y'all there. Now we're going to simplify the top and the bottom. going to get 6 minus x minus 5. And in the bottom, we're going to get x minus 3. We'll have to multiply these two binomials together. That'll give us x squared minus 3x plus 5x minus 15. So we'll get negative x plus 1 in the top. And in the bottom, we'll get x squared plus 3x minus 18. The bottom factors of 18 are 1 and 18, 2 and 9, 3 and 6. So the denominator would factor with a 3 and a 6, but even if you factored it, nothing would cancel. So that's actually your answer. And what are the two excluded values? I've erased my problem. Is it 0? What's in the denominators? X plus 5. I erased the original problem. X plus 5 and x minus 3. So negative 5 and positive 3. Alright, one more. I think y'all have had enough. Let's do one more real quick. We'll just kind of set this next. Okay. These two terms are like terms.
Oh, okay.
And then that little negative x stands by itself.
Okay.
Anybody else question about 70? Alright, last example, 74. So 74 would be, you know, those sections that come at the end that are just a little bit harder. It takes everything that we've done and some of the harder problems. This is one of those that we have to do a couple different things. So in 74, they're asking us to divide and they're asking us to subtract. So it's taking both of those concepts that we learned yesterday and today and putting it all in one problem. So we're going to follow our order of operations, and what would we do first in this problem? Would we divide? Please excuse. Please excuse. We would do what is in parentheses. So in this problem, since the subtraction is in parentheses, you would actually do it first. So tell me about subtracting those two fractions. You got to get a common denominator. And while we're at it, if we're going to divide in the next step, does x squared minus 2x minus 8 not have to be factored? Yeah, so let's just go ahead and factor it. The signs are going to be different. And what multiplies to be negative 8 and combines to be negative 2 would be a negative 4 and a positive 2. Alright, what's our common denominator going to be? X plus 2 times x minus 4, or x minus 4 times x plus 2. Doesn't matter what order we put that in. What are we going to have to multiply the first one by? X plus 2. The second one, x minus 4. Do I need to slow down? Alright, we can't divide yet. We have to subtract our two fractions. So if you know that you're going to have to distribute that negative 1, you can go ahead and write one fraction here. And on the top, we're going to have, you tell me, just to make sure that I know you know what you're doing. X plus 2. You're distributing the negative 1. Negative x plus 4. If you think that you're going to forget to distribute the minus sign, then you'll have to put that extra step in where you write 1 parentheses x plus 2 minus 1 parentheses x minus 4, and you'll see to distribute the negative 1. Alright, so we're almost finished. So we have 1 over x plus 2 times x minus 4. We're going to change division to multiplication, and we're going to flip the fraction over. So the x plus 2, x minus 4 goes to the top. You're going to simplify x plus 2 minus x plus 4. The x's are going to cancel, and 2 plus 4 is 6. So 6 goes to the bottom. Since we're multiplying, it's legal to cancel top bottom. So the x plus 2's and the x minus 4's cancel, and our final answer is 1/6. Are there any restrictions? -2 and +4.